All right, now let's look at complex numbers. This is the first video in a series with complex numbers and just a basic introduction. So let's look at some straightforward problems. X squared is equal to 100. Now, if x squared is equal to 100, then x can equal to either positive 10 or minus 10. And the reason is because 10 squared is 100, but minus 10 squared is also 100. If we have x squared is equal to 25, then we know that x will equal to plus or minus the square root of 25. Obviously, plus or minus 5. It also works when it's not a perfect square. If you have x squared is equal to 7, then you know that x can equal to either positive or negative the square root of 7. The reason is because the square root of 7 times the square root of 7 is the square root of 49, which is 7. And if you had minus the square root of 7 times minus the square root of 7, right? That's outside times outside. Negative times negative is positive. Square root of 7 is square root of 49. And square root of 9 is 7. The problem is that when we have a problem like x squared is equal to minus 36, think of a number that multiplied together is equal to a negative number. And there is not. There's no real number which multiplied together with itself is equal to a negative. So when we're trying to solve a problem like this, we say no real solution. And in many cases we stop there, but in many cases we want to go a little bit further. So let's look at another example real quick. Let's do 3x squared plus 100 is equal to 25. If I want to solve that, the first thing that I notice is that there's only one complicated thing in the whole problem, and that's the x squared. So I'm going to isolate that. So I'm going to subtract 100 from both sides. That's 3x squared is equal to a minus 75. And then I'm going to divide by 3 and divide by 3. And then I get x squared is equal to a minus 25. At that point, I could take the square root of both sides. But when you have a negative on the inside of a square root, then that's no real solution. Sometimes we abbreviate it NRS, or just no real solution, which means that there's no real number that exists which can solve this problem. The way that we get around that is we define what are called imaginary numbers. And the first imaginary number that we define is we define a number to be I, and let I equal to the square root of minus 1. Now this is not a real number, but we can define it to be this. And then we can define complex numbers. A complex number is any number which can be written a plus bi, where a and b are real numbers, and I is equal to the square root of minus 1. And we call this the standard form of a complex number, a plus bi. In other words, it's written in standard form if the real part comes first and the imaginary part comes second. An example of this would be 7 plus 3i. The 7 is the real part. The 3, this is 3 times the square root of minus 1, which is the imaginary part. And let me just show you some example of some complex numbers. You have 7 plus 3i, right? This is the real part and this is the imaginary part. 6i is an example of a complex number. If you want to think about it, 6i is equal to 0 plus 6i. 2 minus 17i, complex number. So is 14. Why is 14 a complex number? Because 14 is just simply 14 times 0i, which in other words, 14 means that 14 is the real part, the imaginary part is 0i, which means there is no imaginary part. Minus 12 is a complex number. So is 3 minus 12i. These are all complex numbers.